Okay, the first property we're going to talk about is the product property of radicals, which is what I just referenced just a minute ago. If you have like indexes and you are multiplying radicals, you can just multiply what's inside, okay? So if I have something like the square root of 2 times the square root of 3, both of those indexes are 2, which means that's just going to be the square root of 6 if I multiply those. As long as they have the same index, you can multiply what's inside. It works the other way. If I have the square root of 6, I can break it up to the square root of 2 and the square root of 3. All right, so you can go back and forth between these properties. All right. To simplify radicals then, what you're going to do is you're going to use your prime factorization. I use the factor tree. Some people use the ladder, whatever it is. You're going to use your prime factorization. You are going to look for something that groups the number of times your index tells you it needs to group. If it groups, then that number can come out. If it does not group, that number stays in. Okay? So let's look at these examples here. Example 1. They want us to simplify these. So I'm going to take the 24, this first one. What is my index here? It's a 2. Remember, if you don't see an index, the index is 2. I am going to do my prime factorization here. So I'm going to say 2 and 12, 2 and 6, 2 and 3. All right. If it groups, it can come out as one number. All right. It can come out as one number. So I have 2 and 2. There are 2 of those. They can come out as one number. They can come out as a 2. All right. If they are grouped on the inside, they come out as 1. All right. What about this guy? Does he have another 2 to group with? No, he does not. What about this 3? He also does not. So on the outside of my radical now, I had 2 that came out. I have a 2 and a 3 that stays in. When they stay in, they get multiplied. Or if multiple numbers come out, they multiply. Okay? So if multiple numbers come out, you're going to multiply them. If multiple numbers stay in, you will multiply them. So my final answer here will be 2 square root of 6. That is what that radical looks like when you simplify it. 2 square root of 6. Okay? Let's look at the next one. We'll do several of these, and then you're going to do some on your own. All right? I'm going to do prime factorization here. So 3 times 25, 5 times 5. What is my index here? What's my index here? 2, right? If you don't see one, it's a 2. All right, so I'm looking for something that groups. I have 2 5s. They group. It can come out as one single 5. What about the 3? It does not group. It stays in as a 3. That is the square root of 75 simplified. 5 square root of 3.
So what's in the box is what?
So we're going to still use our prime factorization here. I typically use the smallest prime I can do is what I typically start with. And then I always have my primes on my left, and so I don't have to worry about them getting hidden. So here I would say like 2 and 20, 2 and 10, 2 and 5. So that's how I would do this prime factorization here. Now, what's my index? 3. So in order to come out of this group, it must group 3 times. All right? So I have 1, 2, 3 of these. That's a group. So they can come out as 1. I can take a 2 out. What about this 5? He does not have 2 other 5s to group with. It has to stay in. All right? So that 5 is going to stay in my radical. What was my index? 3. That has to go back right there. Your index stays the same. So your answer here would be 2 cubed root of 5. 2 cubed root of 5. All right. By the way, what's your smallest prime that goes into 648? 2. 2. Smallest prime. 2. 162, I think. Now we're getting to one that's a little bit, what goes into 81? Yeah, and you can do 9 and 9 here if you want to. Just pay attention that you have primes here. What's my index? 2, so it has to group up by 2s. All right, so I have 2 3s. That's going to come out. I have another set of 3s. Another 3 is going to come out. Any other numbers that can come out? Yeah, I have these. So that's going to come out. What do I have left over? There we go. That's going to stay in. So I need to simplify it. What's going to end up being on the outside? 3 times 3 times 2, which is what? 3 times, yeah, is 9. Times 2 is 18. Square root of 2. That is that number simplified. Okay? So, I mean, we're not. The 14,580. So when you're doing variables, you can expand it. 1, 2, 3. Group them. Whatever can group can come out. Whatever cannot group will stay in. And you'll do it exactly the same way.